We're going to talk about how profuse vomiting from the stomach might cause metabolic alkalosis. And we're going to look at the cellular mechanism for how that happens. So where we are, we're in the stomach, we're in the rugae of the stomach, and then we're going to specifically look at these parietal cells, which is where hydrochloric acid is made. But first, let's look at how hydrochloric acid is made by the parietal cell. And the equation, the chemical equation you're going to see, should look really familiar because it's the same bicarbonate generating reaction that we've seen in red blood cells and that we'll also see in some cells of the kidney tubules.
Secretion of hydrochloric acid. Davenport theory. Hydrochloric acid secretion takes place in the canaliculi of the parietal cells in gastric glands. Energy for this process is obtained from oxidation of glucose. Carbon dioxide is derived from metabolic activities of parietal cell and from blood as well. Carbon dioxide combines with water to form carbonic acid in the presence of carbonic anhydrase. Carbonic acid is a very unstable compound and splits into hydrogen ion and bicarbonate ion. The hydrogen ion is actively pumped into the canaliculi of the parietal cell. At the same time, chloride ion is also pumped into the canaliculus actively. The hydrogen ion combines with the chloride ion, which is derived from the sodium chloride in the blood, to form hydrochloric acid. To make up for the loss of chloride ion, the bicarbonate ion from the parietal cell enters the blood and combines with sodium to form sodium bicarbonate. Factors stimulating the secretion of hydrochloric acid are gastrin, histamine, vagal stimulation.
So let's remind ourselves of the pH scale, which runs from about 1 to 14. So solutions that have a pH of less than 7 are considered acidic. pHs or solutions that have a pH greater than 7 are considered alkaline or basic solutions. And remember that pH literally means power of hydrogen. So I'm also going to show you a bit of a memory trick to help you remember how hydrogen ions or hydroxide ions contribute to pH. So if a solution is becoming more acidic, it means that the amount of or concentration of hydrogen ions has increased. If a solution is becoming more alkaline or more basic, the concentration of hydrogen ions has decreased. So when you talk about these changes, you could say that a solution's pH has decreased, so it's say gone from 6 to 5, but its hydrogen ion concentration has increased. So that looks like this. A decrease in pH is due to an increase in hydrogen ion. But we can also change pH by adding or removing hydroxide ions. Those look like this. Now you may be familiar with this in something like sodium hydroxide, which is part of Lye, Lye. So in the case of the hydroxide ions, we're going to see that as a solution becomes more acidic, as the pH decreases, we would have fewer hydroxide ions. As the solution, or the pH rather of a solution, increases or becomes more alkaline or more basic, then we would have an increase in the number, concentration of hydroxide ions. So over here, I just added a down arrow, a decrease arrow for my hydroxide ions. So what do these hydroxide ions have to do with bicarbonate and hydrochloric acid? I'm going to show you that next. So previously, when we've talked about bicarbonate ion and its power to help buffer blood, we talk about or show the fact that the bicarbonate ion, this one right here, is actually a combination of carbon dioxide gas and hydroxide ion. And the value of that hydroxide ion is that it can bind a hydrogen, and then what we get, these two, is water. So if we're trying to buffer pH, if it's too high, we can add hydrogen ions or remove hydroxide ions. If it's too low, we can do the opposite by removing hydrogen ions or adding hydroxide ions. Now, we've talked about that so far in the context of respiration and carbon dioxide, either holding onto it or expelling more of it. So now let's look at what happens when a person profusely vomits. So that could be from something like the norovirus or the novovirus. It could be from food poisoning, but it could also be from a condition called hyperemesis gravidarum, which means that somehow the bodies of a mother and the child that she's gestating are incompatible, and mom is pushed to the brink of vomiting so often that it becomes really dangerous in terms of electrolyte and water loss for both her and the fetus. So, the bicarbonate ion generation is the same as what we saw in red blood cells. So I'm going to highlight that for us. So this part is all the same. We've seen that before. Previously, the hydrogen ion was a problem, and we had to buffer that or bind it to hemoglobin so that the interior of the red blood cell did not become acidic. And then we had this chloride shift. And the chloride shift pushed that bicarbonate ion out to the bloodstream and moved a chloride ion into the red blood cell to keep electrical neutrality. We're trading an anion for an anion, a negative ion for a negative ion. So here's where that differs with the parietal cell. So if this person is profusely vomiting and they're losing chloric acid, so let's say they're losing 4 hydrochloric acid molecules, then we got to replace those, right? Because the stomach will want to remake the hydrochloric acid so that it has homeostatic levels. And the way that it's going to do that is by generating the hydrogen ion and then bringing in more chloride ions. So every time we put a hydrogen ion out into the stomach lumen along with these chloride ions, simultaneously a bicarbonate ion gets pushed to the bloodstream. So you can see on the right, I remade 4 hydrochloric acid molecules. And then on the left, for every one of those I remade, I had to push a bicarbonate into the bloodstream. So as the amount of bicarbonate ions in blood increases, the number of hydroxide ions in blood increases. And if we go back here to our pH scale, we can see that as the number of hydroxide ions has increased, our pH has now increased further into the alkaline range. So instead of blood having a pH of about 7.4, maybe that pH has gone up to 7.5 or 7.6. And lastly, to correct the common misconception about this question, blood does not become more alkaline because we vomit out hydrochloric acid, it's the remaking of the hydrochloric acid that then pushes more of these bicarbonate ions to the bloodstream, which makes blood more alkaline. Because remember that the bloodstream, the blood vessels, and the lumen of the stomach are completely separate from each other in terms of remaking hydrochloric acid and moving the bicarbonate ions into blood.